All right, so here are the notes for 3.02 parallel lines investigations. So yesterday, or the video before this, we talked about parallel and perpendicular lines. Parallel lines are lines that never touch. Skew lines are lines that never touch but are also not parallel. And then we talked about parallel planes. But today we're going to talk about if lines are parallel and then they're cut by a transversal. So we have that lines M and N are parallel, but then 8 angles are formed when a transversal intersects those lines. Okay, so 8 angles are formed, and under here we have that visual where line M and line N are parallel to each other, and then we have this transversal T, and it has created 1, 2, 3, 4, 5, 6, 7, 8 angles. Okay. What we're about to go over are postulates talking about the relationships between the angles that are formed by this parallel lines being cut by the transversal. Okay, so the first one, it says if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay, so corresponding angle postulate. So this is the corresponding angle postulate. The corresponding angle postulate states that if these 2 parallel lines are cut by that transversal, then corresponding angles are always congruent. These corresponding angles are like angle 1 and angle 5. Okay, so angle 1 and angle 5. Actually, I'm going to go back and do some color. Okay, so angle 1 will be in pink, and angle 5 are congruent. And then we have angle 2 and angle 6 are corresponding. So angle 2 and angle 6. We have, that's an ugly color. We have this light blue, which we can say angle 3 and angle 7 are corresponding. And then last but not least, we can do this orange. Angle 4 and angle 8 are corresponding to each other. I think it's really important for on your notes to draw this actual parallel lines being cut by transversal, and try and find as many colors as you can so you can actually find where all the corresponding angles are. Okay. All right. The next one is the alternate interior angles theorem. So alternate interior angles theorem. Okay, so the alternate interior angles theorem states that if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay, and it wants you to name these angles. So let's find another color. Let's do purple. Okay, so angle, so it's alternate. So alternate means like switched, like opposite. Interior, so it has to be inside the lines of the parallel lines. So that's what it means when it's interior. It's inside the parallel lines. Inside parallel lines. Okay, so we're looking at either 3, 4, 5, and 6. Well, if they're alternate, then angle 3 and angle 6 are congruent to each other. So I'm going to highlight that in purple. And then let's do a dark blue. Angle 4 and angle 5 are congruent to each other. Okay. All right, the next theorem we're going to talk about is the consecutive, or what I say is same side interior angle theorem. Okay, the same side interior angle theorem states that these are supplementary. So same side interior, so it's on the same side of the transversal, but it's inside the lines of the parallel. So that would be angle 3 and angle 5 are supplementary to each other, and then angle 4 and angle 6. Okay, so angle 3 and angle 5 are same side interior, and angle 4 and angle 6 are same side interior. All right, the next one, same side exterior theorem. So it's the same side exterior angle theorem. All right, so again, same side means same side of the transversal, but it's exterior. So exterior is the angles that are outside of the parallels. So this means exterior, and then these angles are exterior. Okay, so if it's same side of the transversal, and I'm going to highlight this. If it's same side of the transversal, okay, that means it's angle 1 and angle 7. So angle 1 and angle 7 are same side exterior angles, and they are supplementary to each other. And then angle 2 and 8. 2 and 8. So angle 2 and angle 8 are also same side exterior. All right, the last theorem, the alternate exterior angle theorem. Alternate exterior angle theorem. Okay, so that theorem states, let's highlight this. That theorem states that alternate exterior angles are congruent. So alternate sides of the transversal, but exterior to the parallel lines. So if we're looking for alternate sides of the transversal, but we're looking at the exterior, so we're talking about 2 and 7, and then 1 and 8. So 2 and 7 and 1 and 8. Okay, so if they're corresponding, or they're alternate interior, alternate exterior, they are always congruent. If they're same side interior, same side exterior, they're supplementary to each other, meaning they add up to 180. Okay, so they add up to 180, and they add up to 180. All right, so let's, why did I do that on that one? Not that one, this one. All right, so let's do some examples. All right, transversal of parallel lines. Okay, so here we are. So we're going to use the diagram, and we're going to talk about the angle pairs with the examples it gives us right here. We're going to use all of these. And we have to determine if they are congruent, supplements, and then we have to name the pair. Okay, so we're talking about 1 and 3. So angle 1 and angle 3. Angle 1 and angle 3 are corresponding angles. So these are corresponding angles. So if they're corresponding angles, they are congruent. So angle 1 and angle 3 go here, and they are corresponding. All right, the next one, 6 and 7. So I'm going to erase. So 6 and 7. All right, so these are on the same side of the transversal, and they are interior. So they're definitely going to be same side interior. And same side interior angles are always congruent. So they were same side interior. So they're supplements. So angle 6 and angle 7 go here. All right, number 4 and 8. All right, so one's on the left side of the transversal, one's on the right, and they're exterior. So they're alternate exterior angles. Alternate exterior angles. So if they're alternate exteriors, they are congruent. So they're going to go under the congruent, angle 4 and angle 8. And they're alternate exterior angles. All right, angle 7 and 8. Oof, this is going to be an old one. So it's angle 7 and angle 8. All right. Well, this is a pair that we have already learned in the past. This is a linear pair. Okay, so this linear pair automatically already tells us that it is a supplement. Okay, because it is a linear pair. Okay, so you have to think of all the pairs that we know. All the pairs that we know. All right. So if you would, finish the rest of these in this box. So you'll have to pause this video, probably like right here, to get all the examples down. All right. Examples. It says, given that R and Q are congruent, or I mean parallel. That's what this line means. This line means parallel. Okay, if you look closely, we have two different transversals here. We have transversal S and we have transversal P. So we have to be careful here. We have to make sure we're not jumping transversals. And let me tell you what I mean by that. Okay? So if I want, it says on number 1, it says name a corresponding angle congruent to angle 3. Okay? If I'm looking at angle 3, I need to make sure I'm not jumping to my yellow highlighted transversal, because I have to stay on the transversal that's creating the same angles with each of these parallel lines. So you have to make sure you stay on this transversal. So if angle 3 is on transversal S, I need to make sure the angle that is corresponding to angle 3 is also on transversal S. So the angle that's corresponding with angle 3 is actually angle 6. Okay. All right. Name an alternate interior angle congruent to 12. So I'm looking for alternate interior angle congruent to 12. Okay, so we're alternate sides of the transversal, but remember, we can't jump transversal. If we start on P, we have to stay on P. So we have angle 12 is on P, so I need alternate sides of the transversal. Okay, so 12 is on the right side. I need an angle on the left side of the transversal, and I need it on the interior of the parallel line. So that would be angle 13. All right, name a same side interior angle supplementary to 4. All right, so we need supplementary to 4. So 1, 2, 3. Okay, name a side, same side, so same side of the transversal, interior to the parallel lines. So like I said, don't jump ship of transversals. You want to stay on the same transversal. So angle 4 has a same side interior angle as angle 8. All right, name an alternate exterior angle congruent to angle 16. Okay, alternate sides of the transversal. So again, 16's on the right side of P, so I need something on the left side of P, and I want it exterior to the parallels. Okay, so it's going to be angle 9. And by the way, guys, like I didn't mention it, but if it starts on one of the parallels, the other angle has to be on the other parallel. It can't be on the same parallel. So that easily, if I wanted So on number 16, it started on the right side of the transversal P. And I said I wanted something on the left side. But exterior, well, it could have been 9 or 15. But 15 is also on parallel line Q. When you start on parallel line Q, you have to jump to parallel line R. So we need something alternate and then exterior to the parallel. So it's angle 9. All right. So then it says that given, find all the measures of the other angles. Angle 1 is 62. Okay, so I want you to think of all the angles we know. Okay, so we're thinking about corresponding angles. We're thinking about vertical angles. We're thinking about alternate interior angles, thinking about it all. Well, I also want to find what angle 2 is. So remember, angle 1 and angle 2 create a linear angle. So in order to find angle 2, I would just take 180 and subtract 62, which gets me 118. So angle 2 is 118. Now I have the ability to find every angle that's on transversal S. So angle 1 and angle 3 are congruent because they are vertical angles. Okay, so angle 1 and angle 3 are vertical angles. Well, angle 1 is also a corresponding angle to angle 8. So angle 8 is also 62 degrees. And then angle 1 is also a alternate exterior angle to angle 6. So angle 6 is also 62 degrees. Okay. All right. So now we need to find everything that's congruent with 118. Well, 2 and 4 are vertical angles, so angle 4 is 118. Okay. Well, angle 2 and angle 5 are corresponding, so angle 5 is also 118. Oh. And then that means angle 7 is an alternate exterior, so angle 7 is also 118. All right. I want you to do all the angles that are with transversal P, but notice this square right here. This square tells us that it is 90 degrees. This should be a very, very easy example to do. All right. Given that lines L and M are parallel, find the value of X. So the first thing you have to do is determine what kind of angles they are. Okay, so we have an angle that is 5x minus 32 and then an angle that is x plus 8. All right, well, I'm thinking to myself, okay, these angles are on the same side as the transversal, this being the transversal. Okay, I like to highlight my transversals. And it's on the inside of the parallel line. So remember, it's interior. It's inside. So the justification for this, it's the same side interior angles. So if they're same side interior angles, then they add up to 180. They are supplementary to each other. Okay, so that's how I'm going to solve for x. I'm going to take both of those angles and add them together, 5x minus 32 plus x plus 8, and set it equal to 180 degrees. Combine like terms, so I have 5x and x. I have negative 32 and 8. So 5x plus x is 6x, and then negative 32 plus 8 is negative 24 equals 180. Now I can solve for x. So I'm going to add 24. I'm left with 6x equals 180 plus 24 is 204. And then divide by 6. X equals 34. Okay. All right, so I want you to try number 7. think about what kind of angles they are. Think about what kind of angles they are. All right. Because if they're anything that's supplementary, you're going to set them equal to 180. But if they are congruent, then you're going to set them equal to each other. So find out if these angles are corresponding, if they're alternate exterior, alternate interior, or vertical, whatever it may be, and then determine how you set them up to solve for x. All right, so this one's a little bit harder, okay? So just bear with me because it doesn't actually have, it has two sets of parallel lines and it has multiple transversals. So I'm going to use 3 different colors to indicate what my parallel lines and my transversal are. So solving for x, I'll highlight in pink. Solving for y, I'll highlight in yellow. And solving for z, I'll highlight in blue because on the notes I highlighted in blue. Okay, so the first thing I'm going to do is solve for x. So I have to determine which parallel lines and a transversal am I going to use to solve for x. Well, I see that x is right here, okay? So it's definitely going to be something on the left side, okay? Well, I do have this 63 here, okay? So let's try this. Let's try this line being the parallel and this line being the parallel. And then this part of the parallel line being the transversal. Okay, here's why I want to do that. If you look at this whole angle right here, and then this angle, I have same side interior. I have same side interior angles. Okay, so if I have same side interior, I know they add up and equal 180 degrees. So I have 3x plus 18. So don't let that scare you, but it's this whole angle. So you have to add 18 plus 63 equals 180. Okay, and the reason why you have to add the whole thing is because that line in between there isn't your transversal. This line next to the 3x is your transversal. So it's including this whole angle right there. This whole angle. And then the 63. And those are the same side interiors. So we have 3x plus 18 plus 64. So we're going to add our 18 and our 63. So 3x plus 81 equals 180. Now we can solve for x. So we're going to subtract 81. 3x equals 180 minus 81 is 99. Divided by 3. X equals 33. Okay. All right. Now I'm going to use yellow to solve for y. So I need to figure out, well, y is right here, so 2y. All right, well, this makes it a little bit easier. So I'm going to use this bottom and this top. And I'm going to use this as your transversal. Well, now I have this 2y and this 18 because this part right here was my transversal. Okay, and this was my parallel line. So, in order to solve for y, this is alternate interior. So, an alternate interior angles are congruent. So, it's 2y equals 18. This one was super easy. Divide by 2. Y equals 9. All right, last but not least, we want to solve for z. Well, z's right here. Okay. So I'm actually going to use this line right here. This parallel line right here. And then I'm going to use this as my transversal again. Okay, so I have this whole angle right here. and then I have this whole angle. Well, I know what x equals now. I know what x equals now, so that's why I can use it. So these, again, are alternate interior angles because they're inside the parallel lines that we chose. Let me see if I can erase. I'm going to erase this and I'm going to re-highlight. So we use this one, and this parallel, or this transversal. So then we have this whole angle right here and 3y. Well, they're alternate interior angles, so that means 3x equals 11z. Well, you know what 11z or 3 what x is. So we can just literally plug it in. So 3 times 33 equals 11z. Well, 3 times 33 is 99. Now we can divide by 11. So z equals 9. Okay, those are a little bit harder, so that's why I like to do those with you, because there's so many parallel lines and so many transversals you can use to actually be successful with this question. Okay, so I hope this helps. Be on the lookout for a assignment help video very, very soon. All right, bye guys.